Hello, and welcome to the search and download website for the Sedimentary Geochemistry and Paleoenvironments Project, or SGP. Our search website is located at sgp-search.io. This video is intended to give you a basic understanding of how to use the website to download deep time geochemical data. The SGP is an open, community-oriented, database-driven research consortium that seeks to address questions of environmental evolution across Earth history through statistical analyses of the sedimentary geochemical record. If you are interested in getting involved, please check out our informational website at sgp.stanford.edu and get in touch with the project leaders. SGP operates in a research consortium framework, modeled after successful consortia in fields like biomedicine. Collaborative team members compile geochemical data and geological context information that we then analyze in group papers. The papers from our first data release, SGP Phase 1, are just starting to be published. This website allows you to search that SGP Phase 1 data product. Meanwhile, SGP team members are busy gathering data throughout Earth history for our second round of papers and data release. Before we dive into the search website itself, I would note that we have a documentation page with information on the website and our application programming interface, or API. There is also a link to a GitHub wiki containing detailed information on the Phase 1 data product. This also contains code and a diagram for our SQL database and extensive information for how we are collecting and coding data in the database. The wiki also contains a full list of references that are contained in the Phase 1 data product and various summary charts, such as the distribution of samples and the percentage of lithologies within the database. Okay, back to the search website. Entering the website, you will see a menu on the left that you can use to create your search. This actually creates an API call that is used to query our database, and I'll show you in the end how you can save that API call for documentation or reuse. Any API call or search query has three parts: a search type, filters, and show. There are three search types that can be used. The samples and no handheld XRF are the ones that most people will use if you're trying to create an output file with rows of samples, their geological context information and age, and a single numerical value for each geochemical analyte. If there are multiple analyses that are recorded in the database for a given analyte for a specific sample, these searches will average the results. The samples and no handheld XRF searches are exactly the same, except that no handheld XRF will exclude any data that was generated with a portable XRF. So let's try a sample search, which is a default for the website. Having our search type, we can now move on to filters. There are both geological filters and geochemical filters. Let's say that I want to download data from Australia. Now we've made it possible to slice and dice the database in many different ways. So for instance, I could select data from Australia that were deposited in rift basins. Although I'm not going to do that right here. By the way, if you're looking to get essentially all the data or all the samples in the database, or at least all of the ones that with age that would be relevant for Earth history studies, probably the easiest way to do that is to go to the geological environmental context and select ages from 0 or -1 to 4,000. You can also filter by geochemical data. So for instance, I could select samples that only have total organic carbon or 2C data by similarly setting our search parameters between 0 and 100%. Or I could select, say, organic rich samples by selecting only samples that have between 0 and 3 and 100% TOC. Although again, I'm not going to do that right now. So having our filters in place, we now decide what we want to show or export to the data file. So thinking about different geochemical analytes that I'd like to see, I might like to see, say, iron speciation. I might want to see total organic carbon. And I might want to see some elemental data like aluminum weight percent, and perhaps a trace metal like molybdenum. We're also going to want to see geological context information. So I go down here to sample context. I might click on site type, so whether it's a core, or outcrop, or cuttings, country, site latitude, site longitude. I might want to know things like long stratigraphy name. That's basically just the geological unit. Lithology name. Interpreted age, which is going to be an absolute age in millions of years, as well as the interpreted age justification, which is going to be a description of why that age was chosen and any uncertainty, as well as minimum and maximum ages for the sample. So I can click search, and then we can now go over and look at the data on the screen on the right. And you can see the header and be able to scroll through your resulting data file. You can also look at this little information box here, which will bring up a light box containing most of the relevant geological context information for a sample, even if you hadn't explicitly picked that as a show feature. All of these will be set up the same. You'll have the SGP's database ID number first, followed by the original sample name from the study, followed by geological context information. So site type, country, they're all from Australia, latitude, longitude, interpreted age, etc., followed by our geochemical data. Finally, we might want to add reference information for this search. So we would go here to this reference tab and click one of these reference searches. The reason I'm doing this last is that including reference information, particularly if you have a lot of samples, significantly slows down search function. So if I select this and search this now, you'll see over on the right, a column with reference information. What this is actually a concatenated set of references for this specific search. So if we look at this sample here, you'll see that it's concatenating together Canfield et al. 2008 and Dahl et al. 2010. And the reason for this is that the iron speciation data was published in Canfield et al. 2008, and the molybdenum data was published in Dahl et al. 2010. So it's concatenating them together. We go down a little further, we see a number of samples that have no geochemical data and also no reference information. These are from a study of the SPICE event by Ben Gill, and these mainly have geochemical information on carbonate proxies, like carbonate-associated sulfate and carbon isotope data. And because none of these were requested in our search, we end up with no reference columns being shown. We can click on through a couple more reference pages, and you get down to this study here, which is showing just one reference, Kreveling et al. 2014. And that's because all of the data that's being shown in this search are coming from that single paper. All right, so let's go back to the start. Once you're satisfied with your search, there are three things that you can do to save the search and the data. First, you can click on the API button. And I realize it doesn't really look like anything is done here, but if you go to something like a blank Word document, you can now paste in the actual API call. And then you can later use this to directly query the website through a Postman API call, or you can include this in a paper so that readers can replicate your search. Next, you can click on this little download button and it'll export a CSV file directly corresponding to what you're seeing here on the website. So let's go take a look at that. So this is our downloaded CSV file, exactly the same as what we had on the website. Database ID, sample name, geological context information, geochemical data, and analysis references. Now, it's important to note that this Australian file, which is pretty extensive, has about 3,000 samples or so in it, is about 1.1 megabytes in size. Of course, this just scratches the surface in terms of the number of samples that we have in the database, the geological context information that's available for each sample, and the amount of geochemical data that's available. We currently have a 10 megabyte download size limit, which we found to be pretty good for almost any kind of normal search that people are running. However, if you would like to download a ton of data, or are interested in custom searches or exports that incorporate geochemical methodology, please get in touch with the SGP leadership team. We'd be happy to help. All right, so we'll go back to the website. The final thing you can do here is click on this little map icon, which will download a map which shows the distribution of samples in your search. So we'll look here of our map of Australia. You see here these Pilbara craton Archean samples over here. You see the Paleoproterozoic and Mesoproterozoic samples from the MacArthur and Roper group up here. Neoproterozoic samples from the Archean, or from the Centralian Superbasin here, and then finally some Mesozoic samples over in Queensland. So that concludes the introduction to the samples and the no handheld XRF searches. Finally, we want to look at what the analysis search can do for us. So we'll go back to the main menu by clicking on the burger bar, and we'll click our Clear All button. We'll switch it on over to analyses, and you see that the possibilities for searching and so forth changes. This is basically all of the same geological search features, but it also has some new things like analysis details that you're able to show. What this search type is going to be able to do is, instead of presenting a sample in a row with its associated geological and geochemical data, it's actually going to produce every single analysis that we have on the database on an individual row. So let's look at a single sample. We'll look at E1101-101.7. This is a siltstone sample from within the Beck-Streaming Dolomite that was collected by Dr. Emmy Smith. Next, we'll click to show some geological context information. So for instance, again, we might want to see things like lithology age or interpreted age. So you go over and look at the data now. Instead of a single sample on a row with all of its data, you're now seeing this one single analyte on a row, specifically the delta 34S value of pyrite. What this actually really allows us to do, though, is get details of the analysis. So we can click down here to analysis details. You can get things like who ran the sample, lab provider name, prep method, that's basically how the sample was ground. You can look at experimental method translation, which is how the sample is dissolved, and analytical method, which is how the sample is analyzed. So we'll click search for that now. And we can go over and see now for this first analysis, delta 34S of pyrite, we can see that the rock was ground in a steel shatterbox. It was then run through chromous chloride reduction, and 34S was ultimately measured on a continuous flow isotope ratio mass spectrometer in the Department of Earth and Planetary Sciences at Harvard University. This is Dave Johnson's lab. So let's say we'd actually made two separate measurements of this sample. That would result in two separate rows, one for each analysis. And if we were looking at these two separate analyses in a sample search, those would actually be averaged together. So let's go down and look at our next analysis. It's nickel. Ground in the same way, not surprising, the powder was produced at the same time. This was dissolved using a 4-acid digestion and measured using ICP-AES at SGS, a commercial geochemistry lab. If we go down farther, we see some samples that look like they have analyses, but there's no data. These are samples that were run, but the analyses were below the detection limit. Finally, we can go back and click on references. In this case, we'll click the long reference, which is the full reference for each paper. You go over here and you actually see that most of these are not associated with references. The reason for this is this unpublished data. However, we can go to the next page and we can see that these iron speciation analyses were published in Sperling et al. 2015. So obviously these analysis searches can give you a lot more information about specific analyses, but are going to become a bit unwieldy for multiple analytes or multiple samples. This concludes the tutorial video on the SGP website, which we hope you'll find useful. The last thing we'd like to mention is that this website is built for the Earth history community, and of course we want to make it as useful as possible for you. So we welcome any suggestions, either directly to SGP leadership or in the comments section of the YouTube video, related to issues with the data, functionality, or anything that you might think might make it more user-friendly to the community. Thank you very much.